For question number 4, we are tasked to find the formula for the volume of a sphere using integration. We can visualize it by graphing the equation x squared plus y squared is equal to r squared and the axis of rotation at the x-axis. We can see in the graph that two of its points touches the x-axis or the axis of rotation. And from what we've learned, we can use the method of discs. And the vertical strips we can only use is the and the strips that we can only use is the vertical strips. So this would be, so dt would become the x. Here now we write down the formula of the method of this, which is dv is equal to integral of pi r squared dt. And now we can now replace our values with from our graph. And now we have the integral of pi y squared dx. Y squared is equal to r squared minus x squared, so we replace it here. And to minimize calculations, we can just get half the volume of the graph and just multiply it by 2 so that we can get the whole volume of the sphere. And so we are now and so our limits would be 0 to r only and times 2. So to get the volume, we have 2 pi times the integral of r squared minus x squared from 0 to r, and integrating it in terms of x, we will have 2 pi quantity of r squared x minus x cubed over 3 from 0 to r. And now we subtract the upper limit and the lower limit. And so we replace x with r. So we have 2 pi is the quantity of r squared times r minus r cubed over 3 minus the lower limit r squared times 0 minus 0 over 3. So this will become 0, and we are now left with 2 pi times the quantity of r cubed minus r cubed over 3. And so we can simplify this further by adding like terms. So r cubed minus r cubed over 3 becomes 2r cubed over 3. And we can distribute 2 pi. And now we are now left. And now we have now our final answer, that the volume of the sphere is equal to 4 pi r cubed over 3.